Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. So we are here today to continue flexibility method. Okay, we are going to analyze this frame. Okay, this beam, not frame, this beam. Okay, this is a beam which has one pin, two rollers. And by looking at this beam, there are four unknown reactions. So this is indeterminate beam. Okay, let's say the question for today is like this. Okay, number one, let's say we have to the statement first. Okay, the beam in the above figure is an indeterminate beam to the first degree of indeterminacy. Okay, the beam is an indeterminate beam to the first degree of indeterminacy. First degree of indeterminacy means DOI equal to 1. Okay. So the question is number 1. Right. The compatibility equation for the beam by considering Y as the redundant force. Okay, that is the first question. Question number 2, reanalyze by taking into account spot settlement which occur at port B. Magnitude 30. Okay. Okay. So we are going to analyze this beam. This is indeterminate beam to the first degree of indeterminacy. Okay. We will consider BY as redundant. We have to write the compatibility equation. Remember, the compatibility equation is used to solve the redundant. Okay, it's used to solve the redundant because after redundant has been determined, then only we can continue to calculate 3 remaining reaction. Okay, and question number 2. Okay, you are asked to reanalyze the beam, but this time taking into account support settlement which occur at support B, okay, of magnitude 30 mm, means that delta B is 30. Delta B is 30. Okay, so this is actually the effect that can be counted when we analyze beam or frame. Normally, support settlement question will be given in either beam or frame question, and it will only affect the actual system. Okay, dia tak affect the displacement in primary, the displacement in redundant. It only affect the value in actual system. For normal case, there is no deflection at support. Support settlement means delta B, which original is equal to 0. Now we change to 30. Support settlement only affect actual system. Okay, please take note. Support settlement only affect actual system, not primary system, not redundant system. Okay, means that we have to do all the process as usual. And when we write compatibility equation, when we need to take into account support settlement, then we have to rewrite the compatibility equation. But this time we have to the equation is equal to the settlement given, not equal to 0 anymore. Do you get the idea? Okay. So without support settlement, do as usual. It is equal to 0 because of the support. Okay. Support settlement occur in actual system. Okay. Occur in actual system. So question number 1 is original without any effect, which the equation is equal to 0. So question number 2, actually we just need to change the 0 to 30. Then we get the new equation, then solve with this new compatibility equation. Okay? So to start this, okay, we need to always start or imagine the end of analysis, means the output, right? So what is the output actually when we analyze this? The output, the final aim, the goal. What is the goal? Reaction. How many unknown reaction? 4 unknown reaction. 4 unknown reaction. So this is the aim, this is the goal. We have to calculate 4 unknown reaction. Okay, these 4 unknown reaction, can we calculate using equilibrium equation only? No. We cannot analyze these 4. We can only analyze 3 using equilibrium equation. So the difference is 1. The difference is 1. So 1 is the redundant. And this redundant, we can determine the redundant using compatibility equation. So that is the goal, the final. Okay, reaction there are 4. 3 can be determined using equilibrium equation. 1 cannot. Okay, 1 cannot. So what we need to do is we have to determine 1 redundant using compatibility equation. Okay, so what is inside the compatibility equation? Compatibility equation is actually displacement, based on displacement. Displacement in primary beam, displacement in redundant beam. Displacement, yeah? Okay, in the displacement formula, what should we have? In the displacement, in the formula to calculate displacement, Okay, start paling top paling top dah clear dah ni, reaction. Reaction. Bawah reaction redundant, right? Bawah reaction redundant, right? Okay, redundant. We determine redundant using compatibility equation. So what is compatibility equation? What is compatibility equation? What is inside? What is the symbol that we use in the compatibility equation? Delta B naught, lagi satu FBB. So FBB and delta B naught ni, what is this? Displacement. So from that we know that we need to have displacement. Then only we can get redundant. Kan? Okay, displacement. There are two displacement. One is delta B naught. One is FBB. Clear that one? Okay, we will have two displacement. We will have two displacement, delta B naught and FBB. Okay, delta B naught belong to which system? Primary system, primary beam. Okay, FBB belong to redundant beam. So how many system actually that we need to analyze? Two beams. So what are we going to analyze when we have two beam, primary beam and redundant beam? What should we do? We are going to calculate displacement delta B naught and FBB. So how to get this? We have to analyze primary beam and redundant beam. That's why tengok pada formula displacement. What is inside the formula? MB, M naught. MB, M naught. So MB, M naught. MB belong to moment equation in redundant, BY applied. That is MB. Okay, M naught. What is M naught? Moment equation in primary beam. Okay, so in order to get moment equation, what is the step before moment equation? What is the step before moment equation? What is the step before moment equation? Okay, on top is 4 unknown reaction. On top 4 unknown reaction, right? 4 yang tadi tu, 4 unknown reaction. Okay, we divide into 3. Kan? 3. These 3 can be solved using equilibrium equation. Okay, and 1 we solve using compatibility equation. Okay? Okay, so compatibility equation is based on displacement delta B naught and FBB inside compatibility equation for this question. Kan, clear that one kan? Okay, there are two displacement called as delta B naught and FBB. Okay. Okay. So now delta B naught. Apa ni delta B naught? We have to integrate. It is MB M naught dx. Apa dia FBB? FBB 1 over EI MB squared dx. Okay, clear. So, di bawah tu, the step before we get this displacement is M naught and MB. Means that we have to have M0 and MB to be the input in the formula, right? We have to have moment equation as the input for the displacement. Without moment equation MB and M0, we cannot calculate displacement. So we need to have two moment equation, M0 and MB. So what is M0? M0 is moment equation from primary. This one is from primary beam, and MB is from redundant beam. Okay? Okay, we have M0 and MB. Means that we have two determinate beam. We have two determinate beam. So in order to write the moment equation, what is the step before having moment equation? What is the step? What is the step before having moment equation? Apa dia? Reaction. So the step before this is reaction. From two system. From two system called as primary beam and redundant beam. Redundant beam or redundant BY applied. Redundant beam is also known as redundant BY applied. Okay. Okay. Always begin with the end in mind. Always begin with the end in mind. Means that itu baru tanda kita faham apa nak buat. Okay, maksudnya kita dah nampak kita punya aim apa? Kita punya aim is to calculate unknown reaction for unknown reaction which we cannot calculate using equilibrium equation only. So that is why flexibility method take place. Okay, so when we apply flexibility method, we will have compatibility equation to solve for the redundant. Okay, to solve for the redundant. And the compatibility equation, what is inside the compatibility equation is two displacement because we have two system. If we have two redundant, we have 6 displacement. When we have one redundant, we have two displacement. When we have two redundant, we have 6 displacement. Okay? So look at the compatibility equation. So what are the input of compatibility equation? Are the two displacement. Okay? So we have to know the formula. So when we analyze beam and frame, these two are the formula to calculate displacement. But when we analyze truss, we will use different formula, right? For truss, we don't use this formula, but we use N times L divided by EI. Okay, that is formula to calculate displacement in truss. Okay, these are the displacement. So displacement ni formula ni we adopt from unit load method. Okay, and of course we modify in order to suit with flexibility method. Okay, so notation we use in the symbol, in the delta B naught symbol and FBB symbol shows the system. Okay, MB M naught. Okay, so MB M naught are the moment equation from two system, primary system and redundant system. And in order to get the moment equation, the step before the moment equation are the step before moment equation. Reaction. Okay, we have to have reaction first. Because in structural analysis, in summary, as I mentioned, in summary, what is structural analysis? Okay, what are the output in structural analysis? When we do analysis, we are actually, number one, calculating reaction. Calculating reaction. With reaction, we continue to calculate internal forces. With reaction. Okay, with reaction, we continue to calculate internal forces. Means that internal forces ni, including moment equation. Moment is internal kan? Internal forces, right? Okay, so moment equation depend on the redundant, on the reaction. Depend on the reaction. So, in order to write moment equation, kena calculate dulu reaction. Without reaction, we cannot have the moment equation. And the third step is displacement. So that is the flow. The third is displacement. The third is displacement. So nak calculate displacement, kena ada moment equation. Kena ada internal forces. Kalau for thrust, N lah member forces. Okay, so remember this step. So we applied all these three steps in flexibility method. Start with reaction, followed by moment equation, then displacement. Okay, displacement. So, tiga ni yang you dah belajar dalam solid mechanics and determinate structure combine dalam satu flexibility method. Okay, so flexibility method. So the secret dia, you kena master dulu tiga-tiga benda ni. Okay, kalau yang ni you still have problem, so you kena enhance baliklah your understanding tu. Okay, so reaction in primary and in redundant. Moment equation pun in primary and in redundant. Okay, so daripada sini, from this, tahu tak apa nak buat? Tahu tak the procedure is actually come from this one, the procedure. The procedure. That is why saya kata kita buat backward, kan? Kita buat backward in order to understand setiap step tu kenapa saya buat ni, kenapa saya buat ni. Okay, jangan hafal start from bottom. Bila start from bottom, kita mungkin ada possibility untuk buat benda-benda yang tak perlu pun. Okay, so kita kena fokus, kita kena avoid unimportant step, do only important step that can be justified. Okay, so back to this. Kita dah tahu dah step nombor 1 kita apa? Step nombor 1, we have to calculate reaction which come from two system, primary beam and redundant beam. So dekat sini, okay, actually dalam ni dia dah bagi dah. Dia tak suruh pun kita kira DOI sebab dia dah bagi tahu dah pun DOI is equal to 1. Kan? And redundant also given. Redundant also given, just use redundant, the redundant given. Okay, kita start dengan solution. Solution. Okay, so in this case, R is equal to BY. R is equal to BY. R, this is one redundant, equal to BY. Okay. Right. Okay, so from this, at this stage, you should be able to write the compatibility equation directly. Okay, the compatibility equation. Yang ni without value lah. Compatibility equation. You don't need to draw the deflected shape. You don't need to derive the compatibility equation. You just need to use the equation. Okay, you just need to use the equation. So compatibility equation for one redundant, okay, is delta. Okay, delta. So I put label R1 because we want to change to numbering. Okay, 1 node. Okay, plus with F11. And remember, F cannot stand alone. Cannot stand alone. We must times back with redundant. So redundant is by. Redundant is by. So this is equal to number 1 equal to 0. Number 1, it is equal to 0. Because number 1, we don't consider the support settlement yet. Okay, this is original. This is original. Delta 1 node plus F11 times redundant by equal to 0. So from this, we know that delta 1 node is displacement in primary system. F11 is displacement due to a unit value of by in redundant system. Okay? So from this, we know that we have to have two system. Okay? So we will have beam, remove remove support B. Okay? So we will have primary beam and redundant beam. So this is redundant by applied. Okay, we will have two. Okay, we will have two system. Okay, two redundant, we have three system. One redundant, we have two system. Okay, now draw the beam. Okay. Orange pula. Sekejap, tukar pakai. Okay. Primary beam. Pin at A. Pin at A. Roller we remove. At B. So this is A, Y, C, Y. $150. Loading here. 150. Okay, and of course we have AX, but AX we know that it is equal to 0 because this is beam. So this is AX. Okay, so this beam has A, B, C, D. $150 kan? 50 only. 50. 50. 50. Okay, distance. Distance 2 meter. Allah. 2. This is 2, this is 2, this is 4. This is 4. Okay, 2 meter, 2 meter, 4 meter. Okay, this is primary beam. Remember the characteristic of primary beam? It is determinate beam. Determinate beam after removing By. So we have 3 unknown reaction now. Okay, Ax, Ay and Cy. It is subjected to 50. Okay, 50 kilonewton at D. 50 kilonewton at D. Okay, redundant, remember it is the same type of beam. The difference is only, okay, the difference is only due to loading. Okay, same type. Okay, when you draw the redundant beam, make sure that you remain support. So just redraw back the primary beam without loading. Okay, and now we will substitute a unit value of By. This is a system, a determinate system subjected to a unit value. Subjected to a unit value of By. Everything inside the redundant system, we must times back with By. So it is actually come from 1 times By. Okay, it is actually come from 1 times By. Okay, and we get F11 times By, right? So everything. 1 times By, F11 times By. Reaction in redundant beam also we have 2 times with By. Okay, so settle the diagram. So now we have primary beam and we have redundant beam. So what we need to do after this? Calculate reaction. We have to calculate reaction. We have to calculate reaction. Calculate reaction in order to write moment equation. Okay, now please calculate reaction. Now please calculate reaction. Okay, now please calculate reaction for both primary beam and redundant beam now. Okay, please calculate. Boleh kira tak reaction? Dah dapat dah? Okay, AY. AY 27.5. 37.5. AY 37.5. CY? Arah tu dah betul dah kan? Arah tu? Oh, arah atas. Arah atas. Dia macam ni lah. Dia macam ni kan? Betul? Betul tak? Yelah kan nak balance dengan 50 tu. Kan? Berapa? 12. 12.5. 12.5. 37.5. Okay. Okay, so AX equal to 0. So this is the primary beam. Okay, what about redundant beam? AY? AY for redundant beam. Negatif 0.5. So dia ke bawah. Dia ke bawah. 0.5. 0.5. Okay. Balance kan? Okay, now we have to cut section. How many cutting section? How many? 1, 2, 3. 3 cutting section. 3 cutting section. So remain 3. Okay, means that both primary and redundant beam must have same cutting section. Okay, moment equation. Moment equation. Okay. Okay, now we will write moment equation. Okay, what is inside the table? We summarize the moment equation in table because we have more than one cutting section. Okay, so for the table, we should have member, then origin, then limit, then M naught and M, in this case M1 lah, M1. Okay, don't mix. If you use B symbol, all use B. If we use one symbol, we all use one. So we have M1 and M0. Okay, M1. This is M. Okay, KD. Okay. So we have M0 and M1. Okay. We have 3 cutting section. Okay, the first section is AD. Second, DB. Third, BC. Okay, origin for AB, origin for AD. Origin. A as origin. DB. D as origin. BC. C as origin. Okay. Okay. Limit 0 to 2, then 0 to 2, 0 to 4. Okay, the first moment equation for AD origin A is the first moment equation. The first moment equation 37.5 M. This is M naught. So what is the equation? X kat sini X. X from origin. So what is the equation? M naught equal to, it is M naught equal to 37.5 X. 37.5 X. Okay, so 37.5 X. Okay, now the next cutting section, DB. Okay, DB macam mana DB? $50. 37.5 M naught. Distance sini X, sini 2. Okay, because origin is D. So what is the equation? Negative M naught plus 37.5, 2 plus X minus 50 X equal 0. So M naught equal to 37.5 times 2. 75 plus 37.5x minus 50. 12 minus lah kan? 12.5x yang ni kan? Okay, it is 75 minus 12.x. 75. Minus 12.x. Okay? This is the second equation. The second equation for D. Okay, now BC. BC equal to BC equal to 12.x. 12.5x. 12.5x. Okay, now move to redundant. Redundant. Okay, the first cutting section AD, M1 is equal to M1 is equal to (0.5x) or negative 0.5x. Negative or positive? Negative. It is negative 0.5x. Negative 0.5x. Okay. What about DB? DB. So it is macam ni. 0.5 kan? Distance ni 2 plus x. 2 plus x. Cos dekat sini. Tadi A, sini D. And x kita mula dari D. Kan? X mula daripada D. So it is ini x kan? So it is 2 plus x. Okay, jangan silap dia punya diagram. Jangan silap letak x tu. Okay, so it is 0.5 times. So it is ni M1. So negative M1 minus 0.5 2 plus x equal to 0. So M1 equal to 1 plus positif or negatif? Negatif lah kan? Negatif 1, negatif 0.5x. Kan? Both are negative, right? Okay, both are negative. It is negative 1 minus 0.5x. It is negative 1 minus 0.5x. Okay, and last one. 0.5x or negative 0.5x. 0.5x or negative 0.5x. Negative. Okay, now please continue to calculate. Displacement. Okay, now we want to calculate displacement. So this one I move. Okay, calculation ni I move to the other side. So next time kau nak refer, you still can refer. Okay. Okay. Okay, now. Okay. Calculate delta 1 node. And this is equal to 1 over EI. Okay, the equation that you have written in the table, actually when you want to calculate displacement, you don't need to rewrite the equation. Okay, you don't need to rewrite the equation. Just use the value in the table and put into calculator and calculate the answer. Just put the answer here. Okay, but doesn't matter. This is the process I show. I will just copy. Okay, so the first section is from 0 to 2. From 0 to 2, it is M1 M naught, right? M1 is negative. Times with 37.5 dx. Plus we have another cutting section. Okay, it is negative 1, negative 0.5. And 75 minus 12.5. Okay, and we have the third section. Okay, we have the third section. The third section. Oh, yang ni pun ubah. Calculation ni saya conting-conting saya ubah . Okay. Okay, it is negative 0.5 and 12.5. L dia tu ni negatif. Bukan. 12.5 12.5 kan. Yang ni 0 to 4. Okay. So okay. So this is for delta 1 node. And another one is F11. Okay, please calculate the displacement Okay, please check Okay, please calculate displacement. Please calculate what do you get for the delta 1 node. Any question? Faham tak ni? Senang je kan? Do you get delta 1 node tu, do you get the same? Do you get the same? 366.67. 66. Okay. Zero point 667. .667 positive 4.667. 5.333. So total is, total dapat apa? Six point 10.667. Okay, 10.667. So we have, okay, got all two displacement, right? So now we substitute into the compatibility equation. Sejuk sangat ni. Sampai nak sampai dikerah. Compatibility equation. Okay. We substitute into this equation to answer question number 1. Kan? Question number 1 without any effect. So do as usual. Okay. So always remain EI because the value that we get displacement, okay, when we divide by EI, then only we get 0.00 something. Okay, so for the compatibility equation, even though EI tu will be cancelled when we want to calculate redundant, so don't cancel too early. Okay, remain compatibility equation in terms of EI. Okay. Tak lain. Before you add, you ambil subjek ni, what do you think about this course before you masuk kelas? Huh? Very hard. Siapa yang cakap? Huh? Lepas dah masuk, susah ke senang? Diam je. Kalau macam ni boleh je buat kan, senang je kan? So compatibility equation is this. Okay, this is compatibility equation. So remain in terms of EI, compatibility equation. You tak boleh bagi equation tu negative 366.666 plus 10.67 BY is equal to 0 as the compatibility equation. Cannot. Compatibility equation, because dia displacement, dia akan jadi displacement when we divide by EI. So kalau kita ada E, kita ada I, we divide by EI, dia akan jadi 0 something kan. So yang tu baru displacement lah. So yang tu baru boleh live without EI. Tapi kalau you pergi cancel kat sini and you give this as equation, cannot. Okay. So we remain EI in compatibility equation. In the equation remain EI. When we solve, then only we cancel EI. So we solve. When we solve, we get BY. Do you spend time and tengok balik semua ni dekat your phone outside class?
Yes.
Okay, good. Okay, equal to so BY is equal to 34.37, is it right? 34.37 kilonewton. Is it your group? I show how we continue to calculate reaction using principle of superposition. Ke tak? Ada dalam video. Tak ingat kelas mana. Okay. Kan kita punya objektif asal kita nak cari the last step means the last step. We analyze remaining 3 using equilibrium equation kan? Okay, we analyze remaining 3 using equilibrium equation. Tapi kalau based on question dia sampai sini je, dia tak perlu pun. Kalau yang ni tak perlu pun kalau based on equation, based on question tadi. Okay, ni sajalah solve kan? Saja solve. Okay, so solve. Lepas tu continue to calculate. Ini kita habiskan step lah kan? Tapi kalau ikut soalan tadi tu dia sampai equation tu je. Okay, okay, dah dapat redundant. We have actually two option. Either we want to kita draw diagram tu, letak nilai BY and calculate remaining using equilibrium equation, right? And we actually have the easier step. Okay, which we can calculate the 3 remaining reaction using principle of superposition. Remember the general equation? Yeah. Okay, that equation. Okay, so because in the diagram, it is actually primary beam plus and in the redundant beam times with BY. BY is 34.37. And in redundant beam, everything inside the beam we must times back with redundant. Because the redundant that we remove. The redundant we remove from the system. So everything. Okay. So this is actually the principle of superposition. Okay. So to get AY, to get AY and CY in this case, AY and CY, what we need to do is just to use the principle of superposition. It is, for example, for AY in actual system is equal to 37.5 plus negative 0.5 times redundant. Mana lagi senang? Okay, you ada dua option. Dah dapat ni kan? Okay, you boleh buat macam ni. Ni 20 kan? Letak BY ni 34.37. Letak sini CY. Letak sini AY. So ini 2, ni 4. Lepas tu you pun buatlah taking moment at A. Lepas tu moment at A kiralah 20 kali 2 minus 34 kali 37 kali 4 minus plus CY kali 8 equal to 0. So dapatlah CY. Ini cara lama, cara biasa, conventional, using equilibrium equation. Instead of using this, we can actually solve the remaining using principle of superposition. Sebab dalam ni kita nak cari AY, kita dah ada AY for both. Kan? Kita dah ada AY for both. Apply the principle of superposition. Yang ni saya bawa tepi So jangan guna cara ni lah. Cara ni lambat. Cara ni lambat. So semua calculation saya letak tepi ni Kalau you nak rujuk. Okay. So we can actually solve the remaining. Okay. We solve. We determine the remaining. How many? 3. Kan? Unknown reaction. Using principle of superposition. Semua video-video end of session saya download dan saya letak dalam YouTube. Okay, please watch. Okay, do regular exercise and please watch. Watch because I discuss different question in different class. So that is why you kena tengok lain-lain juga. Okay, saya tak repeat example ni dah buat dengan you all, saya tak buat lagi dengan the other group. So that kita boleh banyakkan recording tu. Dan ada banyak example yang you boleh refer. And ada benda yang saya dah cakap, dah discuss kat example sana, tak discuss dalam ni. So please tengok. Okay, please watch. Okay, we determine the remaining 3 unknown reaction using principle of superposition as the option beside using equilibrium equation. Because when we have, for example, more structure with more loading, kan panjang dia punya step nak dapat reaction tu kan. So instead of using that, we choose to use principle of superposition. Okay, always remember the general equation. Yang ni tak payah tulis lah. Yang ni general equation ni benda yang you dah remember lah. We derive hari tu kan from the general equation, right? General equation, remember actual beam equal to primary beam plus redundant, redundant BY applied. Okay, so we are going to calculate AY in actual beam. So AY in actual beam is equal to AY in primary beam. It is 37.5. 37.5 ikut formula tu. Plus AY in redundant beam. What is the value? Negative or positive? Negative. Negative 0.5. Okay, times with redundant is 34.37. So what do you get? It is 37 minus 0.5 times 34.37, right? Yeah? 20.31. Everyone? KD? Betul lah kan? 315. Okay? Okay, mana lagi senang? Equilibrium equation or superposition? Superposition. Okay, we have another one. AX 0 tak apalah kan? CY. Okay, we have CY which is equal to, what is CY in primary system? Okay, 12.5 plus negatif juga 0.5. Negatif positif? Tengok pada diagram, positif or negatif? CY, negatif ni. Negatif atau positif? Arah CY tu. Negatif. Arah negatif. Tengok arah dia. Okey, negatif. Negatif. Nanti kita check using equilibrium equation. Okey, check using equilibrium equation. So yang ni is negatif ya. Negatif kali dengan 34.37. 34.37. So what do you get? Negatif 4. 6. 8. 6, 8, 6, 685. Negatif 4.68. Kalau nak pakai 2, 4, 9 lah. 4, 8, 4, silap. Betul lah kan? Negatif 4.685. 69 lah. 69. Okay? Negatif. Negatif. Now, we can check using equilibrium equation. Checking. Ini semua option ya. Option, kita nak just check whether the calculation that we did, is it the right, all the right answer. Okay, checking ni use equilibrium equation. Equilibrium. Equilibrium equation. Okay, how to check using equilibrium equation? Draw the diagram. Okay, draw the diagram. Okay, 30. Okay, AY is 20.32. CY tadi 20. Sini 50 50. Sini 30. 34.37. 34.37. CY negatif. Negatif 4.69. 32 ni. Okay, please check total FY. 50 times 4.69 minus 20.32 minus 34.37. What do you get? Kan? 50 plus 4.69, right? Minus 20.32 minus 34.37. Zero zero. Yang ni checking, dia tak payah, dia tak minta pun, just for you to check. Okay, just for you to check. Okay, actually soalan ni sampai soalan satu tadi sampai ni je tau. Soalan satu tadi sampai sini only. This is question 1. Sampai sini question 1A. Kan? Question 1A. Because we have question 1B. Question 1B analyze the beam by taking into account support settlement. Support settlement which occur at support B of magnitude 30 mm. 30 mm. Support settlement is delta. Support settlement is delta. Which position? B position. B position. What is the magnitude? 30. It is 30 mm, equivalent to negative 0.03. meter. Okay, so kita kan ada equation tadi. B0 plus FBB kan? BY, even though kita pakai 1 tadi kan? So this is negative 0.03. Okay, so when we have support settlement, we will change the zero displacement at B in actual beam to the settlement given. It is 0.03 meter. Okay, 0.03 meter settlement. Okay, jadi clear? Clear? So what we need to do is we take the compatibility equation again. Yeah. Okay. Ni kita masuk consider support settlement at B. So we have new compatibility equation. So we will have new compatibility equation. Okay? When we consider the settlement, we will have new compatibility equation. Okay, new compatibility equation. Okay, so take back this and just change 0 to 0.03 negative. So this is negative 0.03. Okay, so this is the new equation. Okay, after considering or by taking into account support settlement. And for support settlement question like this, when we have compatibility equation and we have support settlement in unit meter, it means that we have to have delta 10 and F11 also in unit meter. Means that we have to have EI. Then only we can solve. Boleh ke solve macam tu? If EI we do not know the value, can we solve for BY? Tadi because equal to 0, kita boleh cancel right? Now we want to solve this, we have to have E and I value. Kita tak boleh simply cancel sebab dia sebab 0.03 is in meter. 366.667 belum in meter lagi. Kan? Bila kita divide with EI, then only we get in meter. Okay? So we have to have, so let's say kat sini kalau EI is given, then you use EI given. If not, you just assume. Okay, assume that E is equal to 200 GPa and I is equal to, okay, let's say it is 500 or 600. Negative 6 mm4. Sekejap, kena tulis pakai equation. Sekejap. It is E equal to 200 GPa. Okay, and I 600 I'm power of 4 meter 4 and 200 GPA equal to 200 times 10 power of 9 jadi Newton. Sebab dalam ni kan all kilonewton. Memang gegau tu 9. Kan? But yang kita analisis semua in kilonewton. So change it to kilonewton. 6 lah kan? 6 kilonewton. Sekejap. Selalunya dalam soalan I ni dia bagi mm tak silap. Sekejap kita try. Because EI ni bila kita nak simplify dia kan. EI ni bila nak simplify, saya double check dulu dia punya kuasa tu. EI, bila kita simplify this EI, this is equal to 200 dengan 10 power of 6. Lepas tu kita kali dengan 600 10 okay, millimeter 4 mm4 milli negative 3 milli negative 3 times milli negative 3 times 4 12 negative this is negative 12 so this is equal to 200 sekejap mm4 betul tak unit saya pakai ni assume E 200 GPA betul dah yang ni 600 sekejap tengok lupa pula tengok saya tengok sekejap past year's paper sekejap nak tengok mm tu nak tengok I tu kan ni 600 10 kuasa 6 mm4 10 kuasa 6 mm4 10 kuasa 6 mm4 okey jadi yang ni 210 power of 6 betul lah. Okey, ada satu kita tinggal. Kat sini 600. Ada lagi satu tertinggal kat sini. Sepuluh kuasa 6 dengan 10 kuasa negatif 12. Okey. Okey. Okey, yang ni. Okey, 200 GPA we change to 206 kilonewton per meter square. Per meter square. Sini per meter square. Meter square. This is meter square. Okay. 200 10 power of 6 kilonewton per meter square kan. Lepas tu I is 600. I is 600. 600 10 power of 6. Okay, mm4. So kita pakai unit SI kan. Kita nak cancel. So 200, this is 200, 200 and 600. So yang ni 10 power of 6, this is 10 power of 6. Yang ni pun 10 power of 6. Yang ni datang daripada mm4. Kan? M milli tu negative 3. Milli tu negative 3 times 4 kan? So that is why solve this kita dapat 200 times 600 only. It is equal to 200 times 600. Because 6 plus 6 minus 12 is equal to 0 kan? And 10 power of 0 is equal to 1. So, dia jadi 200 times 600. Okay, yang ni dapat dari atas. Okay. So, kalau kita play with the unit, it is kilonewton. Kilonewton per dengan meter square ni. Kita kali dengan M kali dengan M4. M4. Ini unit je ni. Fizik. Ingat. Fizik. So kita dapat in unit. Cancel kilonewton meter square. Okay. Okay, now we substitute. Take this. This one we divide by 200 times 600. And this is also same. 200 times 600. Okay. So then only we calculate BY. Then only we calculate BY. So dapat apa tu? 366.666 tu divide by 200 and 600. Berbeza kat situ je pun. So dia akan dapat new BY lah. So we get new BY. This is negative 0.00306. Kamu tak? Please check. Negative 0.000306 plus berapa tu? 10.667 divide by 200 and 600. Dapat apa? 8.89. Yang ni 10 power of negative 5. 10 power of negative 5. Okay. BY equal to Negative 0.333. Okay, now BY is equal to Y equal to 0.00306 tambah divide by 8.89 10 power negative. What is BY? Boleh dapat tak? Banyak tak different? So what is BY? What is BY? Negative 299.33. Sekejap saya nak check jawapan Betul ke 299.33 tu? Macam kalkulator? Macam kalkulator dapat apa? 303. Macam kalkulator? Yang tadi 8.8 yang atas tadi ni 366.66 0.00306 tu dah betul dah. Sekejap, kita tulis macam ni. Kita tulis try kita tulis macam ni tulis macam ni. 3.06 yang ni eksponen negatif 3. Negatif 3. Negatif 3. Okay, and 10.667 divide by 8.89. Okey, 8.89 eksponen negatif 5 tukarkan jadi kuasa negatif 3. Berapa? Bawah 2 titik. .0889. So boleh pakai 10 negatif 3 kan? 0.08889. Eksponen negatif 3. Betul. Okey. So yang ni. So yang ni BY. Sini equal to 0.03 negatif. Negatif. Kan? Negatif. So now BY is negative 0.03 minus plus minus lah 3 point. Ni negatif kan depan? Ni depan negatif kan? Negatif kan? So plus lah kan? Plus 3.06 Exponent negative 3. We divide by 0.0889. Exponent negative 3. 303. We get 303. 303.037. Kan, so ambil yang ni. Ada cara lagi senang tau tak? Rather than you bahagi 2 kali, tapi you kali 2 kali. Sekejap. Sekejap saya tunjuk. Kita dapat sini 303. 3.037 ya. Ini buang. So inilah dia kan. Okey, satu lagi cara. Kita tukarkan 0.03 tu jadi in terms of EI. Yang ni kita ganti EI dalam data one note data dengan F11 kan. So jadi panjanglah step tu 2 kali kita kena bahagi kan. Boleh tak yang ni, yang equation ni, yang equation asal tadi tu, yang ni kan. Okay, ini option. Ni solution je lah. Ni option for solution Option for solution Solution. Ni semua option. Okay, can we take this EI, and bring to this? Kan? Dia jadi negative 3 66.666 plus 10.667 BY kan ni? BY ni equal to negative 0.03 kali dengan EI. Kali dengan EI 200, 600. Mana lagi senang? Okey, cuba solve yang ni. Sama. So dapat 303.037 kilo Newton. Okey, so mana lagi senang? Mana lagi senang?
Yang bawah.
Yang bawah. So pakai yang bawah je lah. Kan? Sebab tujuan kita nak cari BY tu je kan? As long as we get BY. So reanalyze ni maksudnya reanalyze sampai calculate balik remaining reaction jugalah. Okey, cumanya nak tunjuk kat sini yang tadi tu kenapa yang question number 1 pun saya tunjuk juga sampai sampai checking ni kan. Because nak tunjuk pada you the whole process. The whole process. Tapi kalau dalam exam jawab ikut soalan lah. Ikut soalan. So yang ni, so kita nampak tak the quite big difference between without settlement, okay? When we have this without settlement, we get 34.37, right? And when we include settlement, dia akan bagi quite much changes. Okay, BY now change to 303.037. Okay, quite much different. So this is due to support settlement. So in structure, so settlement tu main peranan lah, support settlement. Support settlement main peranan. So when the support, okay, got any support settlement lah. Support settlement ni not only in vertical direction So it is support settlement. Nama common dia is support settlement. Tapi dia akan depending on the position lah. Kalau dia for redundant yang redundant from horizontal, dia akan jadi settlement juga, tapi dia akan panggil support displacement. Because support displacement ni adalah dia macam dia bergerak horizontal, dia akan sama ada move horizontally, right or left. Yang ni settle ni kita assume dia ke bawah lah kan. Settle ni assume ke bawah sebab yang tadi BY tu memang dalam arah vertikal. BY tu adalah force in vertical direction. Kalau nanti kita analyse frame, we may have redundant in vertical direction. Dia ganti AX, dia ganti BX, dia ganti CX kan. In that case, support settlement normally refers to support displacement in horizontal direction. Normally kalau support settlement, support displacement in horizontal direction ni, dia akan bagi tahulah whether it move to the right direction or it move to left direction. Sebab dia akan menentukan negatif positif kita kan. Okay, satu lagi adalah when redundant tu is moment. When redundant is moment, kita boleh ada support rotation. Dia support displacement juga, dia support settlement juga, tapi in rotational direction. So in rotational direction, dia akan bagi kita rotation. Okay, dia akan bagi kita rotation. So setiap satu tu dia akan bagi effect. So memang akan ada effect. So we have to understand now that that effect ni akan main peranan juga because dia akan affect the displacement. So nanti in reality nanti jadi as engineer kan, kalau nak check for displacement ni memang you kena take into account support settlement as well. Okay, support settlement in structure lah, in beam, in frame, in truss as well. Cuma dalam soalan exam, sebab effect of temperature and fabrication error, yang ni dia kerap, yang ni kita memang buat pada truss. So jaranglah you jumpa soalan yang akan tanya efek tu semua dekat truss, tak? Okay, faham tak? Maksudnya beam dengan frame, kalau di soalan tu nak bagi you efek, dia akan bagi support settlement. Kalau soalan tu truss, dia nak tanya you efek, dia akan tanya whether it is due to temperature changes and fabrication error. Okay, so this is how we analyze indeterminate beam considering support settlement. So support settlement ni dia tak kacau dekat kita punya displacement. Masih lagi kita buat proses biasa untuk calculate displacement in primary system and in redundant system. Okay, cuma dia mengubah nilai pada actual system. Okay, mengubah nilai pada actual system sebab dia bukan lagi zero tetapi kita kena letakkan nilai displacement dekat zero tu. Okay, dan lepas tu pilih cara yang paling mudah untuk solve to get the new redundant. The new redundant. Nampak macam efek dia besar lah for this case. Efek dia banyak sebab tadi daripada 30 lebih jadi 300. Okay? Boleh ke? Memang kena do lot of exercise. I believe memang you faham what is flexibility method. Okay? Cuma skill untuk menjawab tu bergantung kepada your practice. Lagi banyak you practice, you lagi mahir buat calculation tu kan. So you akan reduce mistake, careless mistake pun akan reduce. And kalau ada efek, you tahu macam mana nak consider. So you jangan hafal macam mana efek tu masuk. You hafal dia punya konsep. Okay, jangan hafal yang ni kalau yang ni solution kalau tak ada efek, yang ni solution kalau ada efek dia akan jadi banyak. Sebab ini belum masuk lagi efek. Ini efek dia, yang ni efek ni BY dengan redundant, BY tu redundant, efek tu dekat B. Okay, so dia ada banyak lah. So that's why tengok balik yang ni. Kalau ada part-part mana yang still tak faham, please let me know. Boleh tanya. Okay. So cukup dulu untuk yang ni. Support settlement. Of course you can continue until the end lah. Okay, tapi basically I believe yang ni dah cover semua lah. Okay. InsyaAllah we will meet again in the next session.